atmospheric pressure. Learning about atmospheric pressure. Hello students. Today we are going to learn about atmospheric pressure. We all know that force is required to move a stationary object to stop a moving one or to change the direction of an object in motion. We also know that force is required to change the speed of an object or to change its shape. Activity. Take a brick that is used in construction work. The breadth of a brick is twice its thickness and the length is twice its breadth. Take a wooden crate with soil up to a height of about, say, 30 centimeter. Pour water into it to make a layer of thick mud. Place a brick gently on this mud so that it gets embedded in the mud. After some time, remove the brick and observe the imprint on the mud. When the brick is placed horizontally, the area on which it rests is large and the brick sinks only a little. Now let us place the same brick vertically on the mud, a little away from its earlier place. When it is placed vertically, the area on which it rests is smaller and it sinks deeper. When a force is applied to an object, the effect produced on that object depends on the area of the surface on which the force is acting. The greater the surface area, the smaller is the effect produced by the force. Pressure. Force applied on unit area is called pressure. So pressure is equal to force upon area. People use long and broad planks for skiing on ice. The effect of the force applied by this type of boards is reduced and it becomes easier to skiing. The unit of force is Newton, while that of area is square meter or meter square. Hence, the unit of pressure is newtons per square meter, that is N by m square. Thus, we see that increasing surface area decreases pressure, while more pressure is felt if the area is small. Activity. Take a nail which has a flat head and a sharp tip at the other end. Can you hammer the nail into the wall by holding the flat head on the wall? No, you cannot. You can only do it by holding the pointed side against the wall. Why is that? The area of the flat head is greater, while that of the pointed end is relatively very small. As a result, the force applied on the flat head is concentrated onto a very small area, producing greater pressure, and then the nail goes in easily. Needles and knives have sharp points or edges. This makes the actions of piercing or cutting easier by helping us to apply greater pressure on a small area. Does pressure affect substances in the liquid or gaseous state? An activity. Take a plastic bottle with a hole pierced into its side near its base. Fit a narrow glass tube of length 1 centimeter into its hole. Fit a piece of thin rubber over the mouth of the tube and slowly fill the bottle with water. As water collects in the bottle, the piece of rubber bulges and gradually grows bigger and bigger. This tells a student that the water exerts pressure on the walls of the bottle. Why does the pressure increase even though the area of the tube remains the same? Although the area remains unchanged, the mass of the water increases. Therefore, the force increases and so does the pressure. As you blow more and more air into a balloon, its size increases. If you blow it up beyond a point, the balloon bursts. It means that, like liquids, gases also exert pressure on the walls of their containers. We get balloons of many different shapes. If air is filled in a round or oval balloon or one of any other shape, the balloon takes that shape. When you fill your bicycle tube with air, does the tube retain its tube-like shape throughout, or does it get a different shape near the nozzle? Air and water are fluid, that is, flowing substances. Fluid substances exert pressure equally in all directions. That is why they give uniform shapes. Now, take two plastic bottles. Join them near their base by means of a rubber tube. Close the tube with a clamp. Now fill water into both bottles. Fill one bottle completely and the other just a little above the rubber tube. Watch the level of water in the two bottles and what do you see? Now, open the clamp. Water flows from the bottle in which the level of water is higher into the other where the level is lower. The flow of water stops when the level of water in the two bottles becomes equal. Atmospheric pressure. You know that we are surrounded by the atmosphere. You can easily understand that as the atmosphere is made up of gases such as nitrogen, oxygen, water vapor, etc., it must have mass. The atmosphere extends to hundreds of kilometers around the Earth. The pressure that the atmosphere exists is called atmospheric pressure. Considering that the atmosphere extends to hundreds of kilometers, imagine a very tall cylindrical column exerting pressure on unit area. What will this atmosphere pressure be? The mass of the atmosphere standing on the 10 cm by 10 cm area is as tremendous as almost 1000 kg. How do we survive carrying such a tremendous weight on our head? The only reason we do not get crushed is that the pressure inside our body is also the same. That is why we do not feel atmospheric pressure. However, the atmosphere is very important for living things. Activity. Rubber suckers that stick tightly on glass surfaces are available in the market. When properly pressed on the glass, they stick to it. They are difficult to pull away from the glass. Why is this so? When the sucker is pressed onto the flat glass surface, the air between the sucker and the glass is pushed out. As a result, there is very little or no atmospheric pressure there. However, the atmospheric pressure outside pushes the sucker in. This makes it sticky tightly to the glass and it becomes difficult to pull it away. Activity. Take a can made of thin metal sheet with a screw on lid. Pour a little water in it and hit the can. In a little while, the water begins to boil and form steam, which rises out from the can. As the steam leaves the can, it also pushes out the air that was present in it earlier. After some time, close the lid tightly and allow the can cool down. What do you see? After some time, the can gets crushed from all the sides. Why this happens? Otto von Guericke was a German scientist who lived in the 17th century. He had invented a pump which he could use to suck out the air from a closed container. He conducted an experiment in which he joined together two hollow metal hemispheres of diameter 51 cm to form a sphere. Using the pump, he removed the air from inside this hollow sphere. Then he tried very hard to pull the two hemispheres apart, but couldn't do so, due to atmospheric pressure. Even when he used 8 horses to pull at each of the hemispheres, he could not separate them. The strength of so many horses was found wanting when compared to atmospheric pressure. Pumps. You must have seen an ink dropper. It has a rubber bulb at one end, while the other end tapers to a narrow opening. We dip the narrow open end into the ink. On pressing the bulb, the air in it is pushed out of the opening. This reduces the pressure of the air in the bulb. There is atmospheric pressure acting on the surface of the ink in the pot. It pushes the ink into the dropper tube. Now we take out the dropper and hold its opening over the open barrel of the pen. When we press the bulb again, the ink in the tube is pushed out into the pen. How much ink collects in the dropper? Ink enters the dropper till the pressure of the air in the dropper becomes equal to the atmospheric pressure outside acting at its tip. It is because these two pressures are equal that the ink does not fall out of the dropper unless we press the bulb. Thus, it is very clear that the dropper is a kind of pump. The spray pump. The spray we use for spraying holy colors is a kind of pump. It consists of a plastic or metal cylinder with a narrow tube at one end and a lid at the other end. Inside the cylinder is a Suncliffe fitting piston which can be moved up and down inside the cylinder with the help of a rod which passes through a hole in the center of the lid. The narrow end of dye pump is held under the water or any other liquid and the piston is pushed in up to the bottom, thus pushing out all the air from the cylinder through the narrow tube. This reduces the pressure there. Now the piston is pulled up. This causes the liquid to rise into the part of the cylinder below the piston. Now, as the pressure of the water inside is equal to the atmospheric pressure outside, the water does not fall out. To spray dye water or the colors, the piston is pushed in. Under this greater applied pressure, the liquid gushes out of the narrow tube. Air brake. Air brakes are used in trucks, buses, trailers, railway trains, smaller vehicles, aeroplanes, etc. George Westinghouse invented air brakes and first used them on 5th of March 1872 for the railway train. The air brakes consist of a cylinder filled with air and connected to the front as well as rear wheels of the vehicle. When the driver presses the brake pedal, the air in the cylinder gets compressed and its pressure increases. This This causes the brake shoes to rub against the moving wheels and the friction reduces the speed. Summary. Force applied to unit area is called pressure. Pressure is equal to force upon area. The unit of pressure is newtons per square meter, that is N by m square. Fluid substances like liquid and gases exert pressure on the walls of their container. The atmospheric around our body exerts pressure on it. So that is all in this lesson, student. Happy learning!